Okay, so we're going to look at the basics of differentiation. So first of all, we'll look at the notation. So we're used to writing equations as y equals something, but you can also have it as f of x equals whatever, and that could be a quadratic or a cubic or whatever. When we differentiate, we write dy by dx equals whatever, or we can write it as f with a wee dash of x. Okay, they're exactly the same, they're interchangeable, these formats. This is called the first differential. If we differentiate again then, it's called the second differential. And that would be the notation. You can also get different letters, like just because we normally use x and y, because we're normally talking about graphs and that sort of thing, you can also get, so for example, s equals 4t squared plus 3t. And when we differentiate that, we would have ds by dt. Okay, we differentiate the s with respect to t. And what we're actually doing then when we're differentiating is we're finding the gradient of a tangent. So let's look at some basic examples then. So in the following then, we're going to find dy by dx. So our first one, y equals 7x to the power of 6 plus 6x cubed plus 4x plus 7. So when we differentiate, it's the power times the coefficient in front, so that's 42, and then we take one away from the power. So 3 times 6 is 18, and take 1 away. Now really there's a 1 here, so 1 times 4 is 4, and when we take 1 away we would have the power of 0, so x to the power of 0 is just 1, so when we differentiate something just with an x we get that number. Technically, there's an x to the power of 0 here. So when we differentiate a constant, we get 0, so it disappears. Next one then, just be careful with minuses and that sort of thing. And if we have something like this, we'll have to rewrite it first before we can differentiate it. So that would become 3x to the minus 2, that says the same, plus we bring this up, so that's x to the power of minus 3. So when we differentiate that, just be careful of your minuses, we'll get minus 6, x to the minus 3, x, take 1 away, minus 4. And this is a really common mistake people make in differentiation, that add 1 instead of taking 1 away. So it's minus 2 minus 1 to give you minus 3. Minus 3 minus 1 to give you minus 4. Okay, our next one then, y equals 7x squared minus x to the 4 all over x. So we're going to rewrite that. When you've got one thing in the bottom, you can split them up. So we'd have 7x squared over x minus x to the 4 over x. And then using your rules of indices, you'd cancel that down and then would differentiate. So differentiate 7x would get 7. Differentiate minus x cubed, you get minus 3x, take 1 away, squared. Okay, so we've got y equals 7 root of x cubed. So again, we'll have to rewrite that. And you should know that the square root is the same as power of a half. And then again, using your rules of indices, we'd multiply them together. So we can write y as 7x to the power of 3 over 2. So differentiate. 3 over 2 times 7 is 21 over 2. Take 1 away and we get a half. Okay, just using the other notation, fine. You can say this is f dash of x or f prime of x. I usually say f dash. So our function of x is 6x to the power minus 1 minus 3x to the power of minus 3 over 2. So when we differentiate that, we get minus 6x, so minus 1 times 6 gives you minus 6. Take 1 away, we'll get minus 2. Now just be careful with our minuses. We've got minus 3 times minus 3 over 2, so that's plus 9 over 2. And then take 1 away, we get minus 5 over 2. Okay, f of x then equals x to the power of 7 over 2 minus 4. When we differentiate that, we get 7 over 2x. Take 1 away, that will give us 5 over 2. And when we differentiate a constant, it goes to 0. So using other letters then, now we're going to find ds by dt. S is the square root of t. So the first thing we're going to do is rewrite that as s equals t to the power of a half. Now when we differentiate s with respect to t, it's ds by dt. And that's a half t, take 1 away, we get minus a half. And for b, s equals t plus 3 upon t minus 2. So if you get brackets, you have to multiply them out. So that would be t squared plus 3t minus 2t minus 6. So s is t squared plus t minus 6. And then differentiate that. We get 2t plus 1. Remember, that's like a 1 there. And then the minus 6 disappears. And our last ones then, I find dy by dx, so that's the first differential, and d2y by dx squared, which is our second differential. So our first one then, y equals 7x squared plus 12 minus 1 over 2x. So again, we'll have to rewrite that. The first two bits are fine. And again, this is where people make mistakes. The 2 stays where it is. The 2 is staying on the bottom. We're only bringing up that x. It's really x to the power of 1 on the bottom. So when you bring it up, it becomes x to the power minus 1. But the 2 stays where it is. So when we differentiate that, to get dy by dx, we get 14x. Differentiate 12 and it disappears. So differentiate the last term. Minus times a minus gives you a plus. Take 1 away, we get minus 2. Then do a second differential, differentiate again. This time we'll get 14. A half times minus 2 gives you minus 1. And take 1 away and we'll get x to the power of minus 3. And the last one then, y equals 5x to the power of 5 minus 2 over x squared. Again, we'll have to rewrite that. So the first thing we're going to do is separate it. And so both terms will be over x squared. So we're going to have that as 5x cubed. And I'm going to bring this up. So minus 2x to the power minus 2. So differentiate that. We get 15x squared minus 4x to the power of minus 3. Differentiate again. We'll get 30x. Now be careful again with the minuses. This becomes plus 12x to the power of minus 4.